Hi everyone, combination class 2. In this class, I will explain restricted combinations of objects. Restricted combinations of objects. The meaning of this statement is sometimes we exclude particular objects, sometimes we include particular objects. Like when we are selecting a cricket team, sometimes there will be some recommended candidates, so we have to include them. Or if some of them injured, then we must exclude them. So in the class 1, I have explained that what is the number of selections or combinations of n dissimilar objects taken or at a time. Taken or at a time is MCR. So the number of ways of selecting R objects from n dissimilar objects taken or at a time is MCR. Is MCR. Like the number of ways of selecting 2 balls out of 5 balls is 5C2. The number of ways of selecting 2 subjects out of 5 different subjects is 5C2. All right. So this is MCR, the number of ways of selecting R objects out of N objects. All are distinct. Now, the number of ways of selecting R objects from n dissimilar objects such that yes, particular objects are always included. Yes, particular objects are excluded. Excluded means you have to remove those objects. So remove S objects from N objects. Remove S objects from N objects. Now we have N minus objects in our hand. We have N minus objects. We have to select R objects from these N minus S objects. So this can be done N minus S C R. Here I am writing that remove S particular objects from N objects and then select S objects R objects from remaining objects. What is the remaining objects? N minus S objects. So this can be done in N minus S C R. So excluded means you have to remove them. We should not take those objects. Now, what happens if we include them? The number of ways of selecting R objects from N dissimilar objects such that yes, particular objects are always included. They are recommended candidates, like recommended objects, always included, which means that you must take them. You have to take them. Okay. So is N minus S C R minus S. I will explain how N minus S C R minus S. Well, take S objects okay, take S objects one minute. We have to take those S particular objects, In this, there is no selection, those S particular objects. Okay. Totally, we have to select R objects. Now, select remaining R minus S objects. Select remaining N R minus S objects from N minus S objects. From N minus S objects. All right. So this can be done in, we have to select R minus S objects from remaining N minus objects. For example, there are 5 batsmen. We want to select 3 batsmen. But among those 5 candidates, one is the recommended candidate. So you have to take that recommended candidate and then now select 2 more batsmen from the remaining 4 batsmen. So this can be done in 4C2, that is equal to 6. So here particular object is included, particular objects excluded. Excluded means remove them and select the required objects from the remaining. Included means you have to take them and select remaining from the remaining objects. Here are a few questions from asked in that UPSC CSAT exam. Here is a question asked in CSAT 2015. A selection is to be made for 1 post of principal and 2 posts of vice principal. We have to select 1 principal and 2 vice principals. Amongst the 6 candidates called for the interview, only 2 are eligible for the post of principal. Right. Okay, only 2 are eligible for the post of principal, while they are all eligible for the post of vice principal. Remember, whoever eligible for principal, they are all eligible for vice principal. Okay, the number of possible combinations of selectees is dash. Well, we have to select that 1 principal and 2 vice principals. We have to select one principal and 2 vice principals. Okay, all right. See, only 2 are eligible for principal post. Right? Okay, so we have that. First, we have to select the principal post from 2 eligible candidates. So, 1 principal can be selected. From two eligible candidates from two eligible candidates in 2C1 ways. In simply two ways, just two ways. Now, one person already selected for principal. So we have called 6 candidates for an interview. Already a principal post is selected. So there are 5 members left. From those 5 members, we have to select 2 candidates. From those 5 candidates, you have to select 2 candidates. So now select 2 vice principals, from remaining 5 candidates. From remaining 5 candidates. This can be done. This can be done in. We have to select 2 members from 5 candidates. This is 5C2. This is equal to 10. Right? A principal post can be selected from 2 eligible candidates in 2 ways. And 2 vice principals from the remaining 5 candidates can be selected in 5C2 equal to 10 ways. Because whoever eligible for principal are also eligible for the post of vice principal. Here given that for the post of principal, they are all, only 2 are eligible for the post of principal, while they all eligible for the post of vice principal. All right. So here, therefore, the required number of ways equal to principal can be selected in 2 ways, and okay, process is not yet over. So end means multiply. Remaining 2 vice principals can be selected from the remaining candidates in 10 ways. That's equal to 20. Nice, none of the above. So you must read the question very carefully. Here you see that whoever eligible for principal post are also eligible for vice principal. Once principal is selected, and you have to select 2 vice principals from the remaining 5 candidates. Coming to the next question. A student has to opt for 2 subjects out of 5 subjects for a course. We have to select, or we have to opt 2 subjects out of 5 subjects for a course, namely commerce, economics, statistics, mathematics 1 and mathematics 2. Here is a restriction that mathematics 2 can be offered only if mathematics 1 is also opted. Right. So without mathematics 1, there is no mathematics 2. Without mathematics 1, there is no mathematics 2. If someone has taken mathematics 2, then which means that he has to take the maths 1. Anyway, we have to select 2 subjects. We have to select only 2 subjects. So case 1. Case 1. Select M1, Maths 1 and Maths 2. We have selected both subjects, right? So there is only one way. There is only one. You have chosen Maths 2. So then you must choose Maths 1 also. If someone has chosen Maths 1, it is not necessary that he has to choose Maths 2 also. It is not at all necessary. Case 2. Exclude maths 1 or exclude maths 2. Exclude maths 2. Remove the maths 2 subject. Okay. Now select two subjects from remaining 4 subjects. It can be done in 4C2 ways. That's equal to 6 ways. Okay. So be careful here. Either first case or here we have a or. Either you select M1, M2 or remove M2 and then select 2 subjects from commerce, economics, statistics and mathematics 1. This can be done in 6 ways. Here we have a text that or means you have to add the numbers. So therefore, required number of ways equal to. Therefore, required number of ways equal to either 1 way or 6 ways. This is equal to 7. These are the restricted combinations. Include and exclude. If M2 is included, then you must include M1. If M1 is included, it is not necessary that M2 has to be included. Well, coming to next question. This is a previous JEE main, of course. It is the level of CSAT exam. A scientific committee is to be formed from 6 Indians and 8 foreigners, which include at least 2 Indians and double the number of foreigners as Indians. A scientific committee is to be formed from 6 Indians and 8 foreigners, which include at least 2 Indians and double the number of foreigners as Indians. The number of ways of the committee can be formed is. So here you have to include at least 2 Indians. At least 2 Indians. Which means that you can include 2 Indians, 3 Indians, 4 Indians maximum. Why? You have to select the number of foreigners as double of the Indians. If you select 2 Indians, you have to select 4 foreigners. If you select 3 Indians, you have to select 6 foreigners. If you select 4 Indians, you have to select 8 foreigners. You cannot select Indians more than 4. Well, so here I'll write a table that is a very simple. See, here Indians. Next, foreigners. Okay. So we have Indians 6 and foreigners 8. Well, suppose if you select 2 Indians, you must select 4 foreigners. If you select 2 Indians, you must select 4 foreigners. Now, which means that select 2 Indians from 6 Indians, that is 6C2 into, because end, right? You have to select 8 foreigners from, you have to select 4 foreigners from 8 foreigners. That is 8C. I will calculate it later on. Now, if you select 3 Indians, here or, okay, here end, here end. 2 Indians and 4 foreigners, or 3 Indians and 6 foreigners. So this can be done in select 3 Indians from 6 Indians and 8 foreigners from 6 foreigners from 8 foreigners equal. I'll write that number. Or last case, if you select 4 Indians, then you have to select 8 foreigners from 8 foreigners. This can be done in 6C4 into 8C8. So 6C4 means it is 6C2. You will get 15. 6C3 is nothing but 20. Here I'll write 6C3 into 8C6 is nothing but 20 into 8 into 7 by 2. It is 4, 560. And 6C2 into 8C4. I'll calculate this. So therefore, the total number of required ways equal to adding these, you will get 1625. This question is eligible for CSAT exam. Select at least 2 Indians and double up the number of foreigners as Indians. A committee of 11 members is to be formed. A committee of 11 members is to be formed from 8 males, 5 females. There is a restriction. If M is the number of ways of the committee formed with at least 6 males, and N is the number of committees formed with at least 3 females. Okay, we'll calculate this using a table. First, we will calculate the number of committees with at least 6 males. Well, I'll write here. Males. Okay, we have 8 males. And females. We have 5 females. We want to select 11 members, remember. So if you select 6 males, you have to select 5 females. You have to select 5 females. If you select 7 males, then you have to select 4 females. If you select 8 males, then you have to select 3 females. Now, you can't select more than 8 males because there are only 8 males. So now, for this, the number of selections is you have to select 6 males out of 8 males. So therefore, this can be done in 8C6 into 5C5. This is equal to 28. For the second case, or here overall, you have to select 8 males. So 8C7 into 4 females out of 5. 5C4. It is 8C7 is nothing but 8, 5C4 is nothing but 5, so totally 40. Or the third possible case is 8C8 because we have to select 8 males, then 3 females, 5C3. 8C8 is 1 and 5C3 is 10. So this is totally 50, 78. This is the number denoted by M. M is the number of ways the committee formed with at least 6 males. If once you understand this, you can do the N is the number of committees is formed with at least 3 females. With at least 3 females. Well, I hope that we need not to calculate N. Because here M equal to N. See, here we want to calculate that N is the number of committee is formed with at least 3 females. Means 3, 4, 5. We got the same table. We got the same table. If you want, I'll write females and males. You will get the same table and same number of ways. Here 3, here 8. You start whenever they say that at least. If they say at most, decrease 1 by 1. If they say at least, you start from there onwards, increase 1 by 1. 3, 4, 7, 5, and then 6. You got the same. So therefore, that N is also 78. So that's why M equal to N equal to 78. Here is a question based on combinations. CSAT 2019 question. The number of times that the digit will appear while writing the integers from 1 to 1000. Whether it is 5, whether it is 1, whether it is 9, whether it is 4, everyone will have the same. It doesn't matter whether 5, they ask 5, 6, 7, 1, whatever it may be. Okay, list out. We don't list out all the numbers. It is very difficult. How many times the digit 5 will appear when we are writing integers from 1 to 1000. If you write all the numbers from 1 to 1000, you have to count that how many times 5 will appear in that list. Well, so here the point is, we'll calculate in a simplest manner. Case 1. Case 1. The numbers consisting only 1, 5. The numbers consisting only 1, 5. The numbers which contain 1, 5. Only 1, 5. Okay, only 1, 5. Again, I will use the box system. Well, all right. Maximum is 3-digit number. Maximum is a 3-digit number. Now, first you have to place the 5 in one of these 3 boxes. Place the 5 in one of these 3 boxes. Okay. So 5 can be placed. 5 can be placed. Can be placed in 3 ways. In 3 ways. either first place or second place or third place. Well, so there are three ways. Now remove the 5. Remove the 5. Suppose, for example, 5 is here. For example, 5 is here. Well, okay. This place can be filled in. This place can be filled in. Remove 0 and 5. Remove 0 and 5. So this place can be filled in. No. Wait a minute. Suppose the first unit place is 5, for example. Now this place can be filled in 9 ways. Okay. 0 to 9. 0 to 9. Excluding 5. Excluding 5. Because we want to write all the numbers which contain only one 5. Single digit numbers, 2-digit numbers, 3-digit numbers. Okay. The second box can also be filled in 9 ways. Same. 0 to 9 except 5. Now you may get a doubt. Are we calculating 3-digit numbers or 2-digit numbers or single-digit numbers? See, suppose the first box is 0 and the second box is 0, then it represents a single-digit number. Suppose first box is a 0, second box is non-zero, then it represents a 2-digit number. Suppose first box is non-zero, then the number represents a 3-digit number. Right. So these are 9 into 9 for one place. Similarly, if you put 5 in the middle place, then also 81 ways. If you put 5 in the first box, then also there are 81 numbers, right? Always. There are 81 numbers. There are 81 numbers. 81 numbers for each case. For each case. Means when the 5 is in third place, there are 81 numbers. When 5 is in middle place, there are 81 numbers. When 5 is in first place, then also there are 81 numbers. Okay, so therefore, the number of times that 5 appear only 1. Okay, so okay. There are 81 into 3, that's equal to 243 numbers. 243 numbers which contain single 5. Which contain single 5. Only one 5. All right. So, which means that there are 243 numbers which have only one 5. So 5 is counted 243 times. Now case 2. Case 2 is simple. The case 2 is if the numbers contain 2 5s. This is the number of numbers, or to count the numbers containing 2 5s. To count the numbers from 1 to 1000 only, numbers containing 2 5s. Containing 2 5s. Okay, that is, the number should contain 5, 5. Okay, you see, it is a very simple task. Suppose 2 5s are placed in first two boxes. First two boxes. Well, now this place can be filled in 9 ways, excluding 0. Excluding 0. Right? Excluding, not 0, excluding 5. Excluding 5. Or suppose those 2 5s occupied last 2 places, here and here. Then this can be filled in 9 ways. The meaning of the first statement is there are 9 numbers which contain first 2 places 5 and 5. Third case. First digit is 5, last digit is 5. Now, this can be filled in 9 ways. 0 to 9, excluding 5. Okay, so therefore, there are 27 numbers. There are 27 numbers which contain 2 5s. Which contain 2 5s. There are 27 numbers which contain 2 5s. So in these 20, in each number, there are 2 5s. Like that, there are 27 numbers. So we count 54 5s. Okay. So there are 54 5s. 54 5s in these 27 numbers. These 27 numbers. And there are 243 numbers which all contain single 5. Which all contain single 5. 5 is counted 243 times. Now case 3. The numbers which contain 3 5s, that is only 1. 5, 5, 5. There are 3 5s. There are 3 5s. Again, I am telling whether you list out 1s or 2s or 3s or 4s or 5s or 6s or 9s from 1 to 1000, you will get the same number. So therefore, the number of 5s, the number of 5s when listed from 1 to 1000, when listed from 1 to 1000, from 1 to 1000, we get is 243. There are 243 numbers which contain single 5. Okay. And there are 54 5s containing 2 5s. Means 27 numbers. Plus, there is only one number which contains 3 5s. This is equal to 300. That's equal to 300. Whether you count 1s or 2s or 3s or 4s, you will get the same number. You will get the same number. Here is one more question based on committees. Consider a class of 5 girls and 7 boys. The number of different teams consisting of 2 girls and 3 boys that can be formed from this class. Okay, we have to form 5-member committee, 2 girls and 3 boys. If there are 2 specific boys, A and B, who refuse to be the members of the same team, means they don't want to serve in the same committee. They are enemies to each other. Either both will be eliminated from the committee, or one will be in the committee and one will be the outside of the committee, or neither of them will be in the committee. Right. So instead of calculating all these possible cases, let us count that without restriction minus when both specific boys A and B serve together in the committee. Total minus they serve together. Once again, total number of committees without restriction minus when they serve together in the committee. We have to eliminate when both are in the same committee. When both are in the same committee. Okay. So we have to eliminate the number of committees we have to eliminate the committees which include A and B from total committees. From total number of committees. Well, so therefore, the total number of committees equal to the total number of committees. Okay, equal to, we have to select 2 girls out of 5 girls, and we have to select 3 boys out of 7 boys. So that's equal to 10 into 7 into 6 into 5 by 3 factorial. That is equal to 350. Okay, these are the total number of committees. Now we have to eliminate the committees which include A and B. Here, the number of committees which include both the boys, which include the specific boys, A and B. Is, okay. Anyway, there is no restriction on the girls. So select the girls as usual. So 2 girls can be selected from 5 girls in 5C2 into. See, already we have taken 2 boys A and B. Already we have taken 2 boys A and B, and we have to select one more boy from the remaining 5 boys. One more boy from the remaining 5 boys. So that is 5C1 equal to, this is 10 into 5 equal to 50. we have to remove these committees from the total. So therefore, the required ways equal to 350 minus 50 equal to 300. So there are totally 300 committees. We have done in a complementary system. Instead of listing out all possible cases, we have removed the number of committees in which both together serve in the committee from the total number of committees. So option B is correct. In the next class, I will explain geometrical combinations, like if there are some points on a circle, how many equilateral triangles can be formed, how many diagonals can be formed, okay, how many right angle triangle can be formed, etc. I will explain in the coming class.